Hi, this is Real World Audio, and this is a comic episode, I would say, because I'm going to address a very interesting issue that some people bring up for modern amplifiers, Class D amplifiers, as a big advantage against Class A tube amplifiers, that they use very little power and they save on your electric bill. So let's have a real look at this thing. Are you truly saving on your electric bill if you have a modern Class D amplifier with a matching low efficiency loudspeaker system, which is like a modern system, versus like a 60s era system when you had a Class A tube amplifier with very high efficiency loudspeakers? And the title I gave it is The Audio World Turned Upside Down, because back in the 60s we had low efficiency amplifiers, which means that you needed a lot of watts to get a few watts output, but high efficiency loudspeaker, which means you needed just a few watts to have a very loud SPL output. And now modern systems are other. I flipped to the other side. So now we have very efficient amplifiers, which means that basically you get almost very close to 100% efficiency for the power output versus power consumption, but we have low efficiency loudspeakers. So let's count our money in the pocket of how that translates, and also let's see what is the energy consumption at various levels. So let's see what's going on. So when we have those tube amplifiers, and for that let's use a 300B as an example. Let's say we have a pair of 300B monoblocks, and here what's happening is that they are going to consume like between like 50, 60, 70 watts or so per channel constantly. And it doesn't matter whether you are listening to any music at all or you are blasting them, they consume the same amount of power anyway. But this is not a waste. So people call it that Class A amplifiers, they waste power, but that's not true, because that power is not wasted. That is used to create a constant reserve and steady operating points. It's like having a lot of energy put into a goal to keep the conditions unchanging, regardless of you playing very soft material or very loud. And this is the secret why Class A amplifiers have much better low-level detail capacity and much lower distortion parameters and figures compared to very efficient amplifiers, because they provide constant operating conditions for their amplifying elements. So basically you have an ocean and you need to use a drop. And how much? Let's have a look at a 300B as an example. So basically for a 300B tube, you need 35 watts of plate dissipation. So it means that you need to supply the power tube with 35 watts as high voltage juice. And that 35 watts, that's the majority. That's why your room is getting heated, because that's the main component why the tuba is heating. So that's that big black thing inside the plate that's going to radiate that heat into the room. And 35 watts, how much is that? Well, when you have a heater, the heaters in your room are like 10,000 watts. So if you want a heater, then it's like between 3 to 10,000 watts that you use in your room in a winter. So if you are worried about 35 watts, I here live in Hawaii, it's very hot, but if I have a pair of monoblocks like this, I don't even notice whether they are turned on or off. But as you know, here it's very hot, very humid, and every single watt counts. But if you have a normal living room, then this is not going to make any difference whatsoever. If you have a very small room, then you might see some differences. And of course, there are tube amplifiers which produce much more heat. However, for the purpose of this video, I'm making this comparison because I'm using comparable partners. So let's just scroll here. Why are they comparable? Because here in the case of this 300B amp, there is an 8 watt peak power output in class A, and they are matched with 103 dB per watt meter efficient loudspeakers, and the peak SPL achievable is 112 decibels per meter. When we look at a modern example, so if you have this Wilson loudspeaker, about 83 dB per watt meter efficiency, and you pair it with an 800 watt per channel class D amplifier, you can get also the same 112 dB SPL out of that per channel as you get from this combo. Now I think many people are surprised that 800 watts with a modern loudspeaker give you the same peak sound pressure as 8 watts did with a very efficient loudspeaker. But that's the reality. And that's why I'm using the example of 300B, because that gives you that 8 watts per channel. And now some people would say that, ooh, that when I look at this Wilson Sabrina, they make show that it's much more efficient than that. It's not low 80s, it's high 80s. But yes, guys, read the specifications. It's not specified at watt meter, it's specified at that 2.83 volts meter. And when you convert that into watt meter figure, it's much closer to low 80s compared to high 80s. Okay, now let's go back. Where did we leave our train of thought? So basically, for our 300B amp, we have that 35 watt plate dissipation, and basically that gives us the peak, that this is how much energy there is in our power supply. This is the energy the power supply is providing the tubes. So basically this is how much juice this tube amplifier has. And how much does it need? It needs 200 milliwatts, so 0.2 watts for very loud passages. So let's say that if we call a milliwatt a $1 deposit in the bank, then the 35 watts that your tube is receiving from the power supply, that is equivalent to having $35,000 in the bank. And for a loud passage, you need $200. So this is the case of a person who has a bank account and who has a debit card, and he needs to draw very little money from a supply of that is bountiful, plentiful, and you have more than 100 times in the bank that you would need for a loud passage. Now let's see the example of a modern Class D amplifier. So here, because it's not dissipating anything more than it needs, you have nothing in the bank. You need to wait for the bank transfer. So it means that your supply, your power supply's behavior changes with the demand that you are asking from with your Class D chip. And of course, yeah, there's a big transformer there. There are big power supply capacitors. So I would say that you have a big supply if we measure it in farads. True, but this is not a currency that is a fixed currency. So depending on what is your actual need, the exchange rate of this currency fluctuates. So you are going to get different rates for those times when you demand very little money or very little power demand, compared to when you are draining your passage. And because you have this dynamic charging and discharging of your power supply, it has an unequal load on your power transformer. So your power transformer is asked to draw just milliwatts, like trickle amount of power from the wall in the very short or very soft passages, versus when you have a high passage, you need to draw over 1000 watts of juice from your power line. And as you know, that creates a very big difference in how the power supply behaves, how your capacitors charge from that power transformer when the demand and the supply fluctuates so much. So basically, you do not have a stable bank. You have a variable exchange rate, fluid credit supply behind you, and instead of that 0.2 watt for a loud passage, for the exact same SPL you need 20 watts. So basically, instead of drawing $200 from your $35,000 bank account, you need to draw $20,000 from a fluctuating bank account, where you need to wait for the transfer to get exchanged from the wall, because there's no steady supply. So here we go. In a Class D case, we have no stable reserves. Of course you have reserves, but they are not stable. You don't have stability, and you need to just draw insane amounts of money. So now we went through all of these things, and here goes the letdown for those people who think that they are saving big time on electricity bill by using a Class D amplifier and the modern system with low efficiency loudspeaker. The problem here is that even though you are saving on the amp, that's very true, but instead of needing just a very trickle amount of power, you need power in the 100 watt levels, because your loudspeaker is the point where the energy is wasted. So in the case of an older, like in the 60s system where we are here, the power got wasted there, but it did not go to waste, because it was used to create a stable, constant supply of energy. And in the case of a modern system, we are wasting about the same amount of energy, but not in the amp, but in the loudspeaker. And how is that different? Because we waste here, we waste there. But here, the waste goes to create an ideal condition of a stable power supply. And here, the waste goes to rob you from 20 dB dynamic headroom, because when you have a lower efficiency loudspeaker, it does not mean that you need much more watts to get the same loud SPL. It also means that you are losing that much dB of dynamic headroom. So basically, if you listen to the same music material on a modern system compared to this high efficiency loudspeaker Class A combo, it has the same effect as if you took that modern recording, you put 20 dB dynamic compression on it and you played it in that in the tube system. That's how you would hear it. So basically, in a modern system, the wasting at the loudspeaker creates compression, severe compression, and the wasting in the power for the tube amplifier creates a very favorable condition for both low output power and high output power. And now let's look at exact figures. So how many watts are you paying and are you doing? So if we are listening at a 65 dB average SPL, then in with this scenario, with this tube amplifier high efficiency loudspeaker combination, we get a constant 100 to 150 watts power consumptions for the both channels, and 160 microwatts per channel are used up for music. And for your high power Class D low efficiency loudspeaker combo, you are just depending on that Class D amp, you are just using a few watts. So basically you are saving about 80 to 100 watts per hour on your electric bill when you are listening to quiet music. Now, will you be listening to quiet music with a Class D combo? Hell no. You know why? Because of the dynamic compression of a low efficiency loudspeaker, you need to crank up the volume. Just think about Steve Gutenberg, the audiophiliac, when he's talking about there is just one setting on the volume control where the system sounds good. And even if you go one tick down, it loses life, loses power. And if you go one tick up, it's already too loud. And that's because of the dynamic compression of the low efficiency drivers. So you are not going to enjoy this scenario when you are saving the watts, you are saving the money. And however, with an efficient loudspeaker driven by a low power tube amp, you are going to enjoy it at low SPLs because you still have the dynamic headroom. Now let's see when you are blasting them. So you want to call the cop. The neighbors want to call the cops on you. 105 dB average SPL. In that case, your modern scenario, you are taxing it to get for the two channels over 300 watts of electricity, and your tube amp is still clocking around 150 watts depending on the exact amp you have. So basically you are losing about 200 watts per hour when you are blasting your modern system. So if your main reason is that you want to be environmentally friendly, that's why you are getting Class D amp, then your reasoning is not right, because your Class D amp with your low efficiency loudspeaker is going to lose you money on your electric bill versus your low power amp with a high efficiency loudspeaker. So thank you guys for tuning in. Have a wonderful day. Bye bye.